Hello everyone, nice to see you again. I'm Chris. In this video, I'll show you how to use Codesys to build a EtherCAT network. And this side, you see I'm using the touch panel come from Exa EX707M. It installed in a Codesys one side, Codesys one time is installed inside, and it will be a EtherCAT master root, and then to flow all the package to this stuff is come from Becchoff. For example, the EK1101, the EtherCAT coupler, and EL6910, the FSO, the logic terminal, and then here is the safety terminal. And you see here I'm using it. I also show that I'm using the FSO because I'll show you that there's some plugin that for Codesys allow you to control the EL6910 to build the safety logic in your Codesys IDE, and then down the safety project into the EL6910 to build your safety network. Okay, let's start. Before I explain this video, these conversations, let me introduce me again. I'm Chris. I come from Hong Kong. Now I am doing some automation, factory automation stuff. And in the left hand side, you see is my Twitter, my blog, and my YouTube channel. If you like me, you can just follow me and then to just say hi to me. Okay, so let's back to our slide. Your question is, how can I build a safety logic in my Codesys IDE? The answer is I will use a plugin called Codesys Safety for EtherCAT Safety Module. So here is the screen. Here is the pictures that I took from Codesys website. So you can see here if the Codesys PLC with EtherCAT master. In here it no need a safety PLC. So in this side it will be my Exa panel EX707M, and with Codesys runtime inside. Then here you see EtherCAT safe module and safe E/AS. So in here you will find a this side will be the Becchoff EK1101, the EtherCAT coupler. And here will be the EL6901, the terminal of the TwinSAFE logic. And here will be some safety IOs, and here will be some other FSO server drive. And here, then you see the level should be up to SIR3. And here is the logical module is support from this plugin. You can use EL6900 or EL6900 or EL6910 with a TwinSAFE logic, or you can also use EK1960 and also other terminal. So I will not explain too much in here, but in this video I'll use EL6910. And for digital is AR3 IO modules can be used, and for not just Becchoff but also all other manufacturers. For the analog, it's SIR2 input module is support. It also supports standard signals, multiple, and groups. And without the license, you can still 1-2 hours without any problems. So here is a screenshot that I will config with you in this video. So in the left hand side, this is the configurations. Here you see I have a EtherCAT master, I have a coupler, then here is my TwinSAFE PLC, and here is EL6910. In here you will see I have a safety logic in here, then I have some safety module in after that in the same coupler. And you see there's an orange icon here, so it means that this module they need a special license, and because I don't have, so it should be the orange icon in here. It will stop in after 2 hours. In the right hand side, it is the safety IDE of Codesys. In here you can use the for example e-stop function blocks or two-hand function block or etc. So now explain the hardware I'm using this time. The first one I'm using is EL6910. It's a EtherCAT terminal communication interface with a TwinSAFE logic. It's able to process the analog data because there's an old generation called EL6900. It only can process the boot type data. And by using this module, you can check the history of your dynamic informations and or get the current status of your device. You can up to 212 safety connections and up to 100 and 28 TwinSAFE groups and 14 users. But not just FSO, you can also use PokeSafe Master, Slave Support, and TwinSAFE SC. It also provides a incremental download. So what is this feature? It's very interesting features because you can check the menu, because the EL6910 actually it will separate the parts for the checksums. For example, the parameters and program, etc. It will download the part that the checksum is changed, so it will be a very efficiency rate for you to download your project. And this one is EL1910 is a EtherCAT terminal, 4-channel digital input with TwinSAFE. So you have 4 safety inputs. You have cross circuit detections, 1-channel and 2-channel validation directly on the components, and you can testing of the channel can be activated. So here is the other terminal they are using in this video. Is EL2904. It's a 4 safe output and integrated circuit measurement testing of the channels that can be activated. If the standard output can be activated also. And finally, so here just Codesys runtime that I installed the hardware that I installed the Trinket runtime, but installed the Codesys runtime. It is the EXA, is the Italian manufacturer. I'm using the EX707M. So it's a 7-inch touchscreen. Then it's a 64-bit core CPU, and with Codesys Wi-Fi, and you can use all the Ethernet I/O stacks, and the network, all the network is applications. You can up to depends on your configurations. You can use up to separate on your network up to 3 Ethernet. And in the behind, you can also use some plug-in modules for your application, for example, CAN or Modbus, etc. And finally, is multiple touch operations is allowed. Okay, I think my introduction here is enough. Now I turn on my camera and then just show you actually the hardware I'm using in this time. Okay, now here is the camera that I turned on, and you can see the hardware that I'm using in this time. So the Codesys runtime I installed is inside this panel. It is a touch panel come from EXA. The model number is EX707M, and here is I use an Ethernet cable to connect the network from my EXA panel to EtherCAT coupler from Becchoff. And here you will see that here is the EL6910, this TwinSAFE terminal in here, and here is the safety input and the safety output. In this tutorial, I only use this one, the first TwinSAFE safety module, safety input module, and here that is the emergency stop is connecting to this EL1904. And then in this card is EL2904, and it's connecting to this 2 relay. Okay, so I think the explanation of the hardware I'm using this time is enough. Now I will turn on Codesys. I open Codesys, and then we can configure and make some safety program together. Let's start. Okay, now I start my Codesys ID. Now we can start to configure our project. So go to Final, New Project, and just press OK. And then for the device, I choose the device you're using this time. In this case, I'm using the extra panel EX707M, so I choose EX70700M, and just press OK. Great, and then you can see I create a new project. So first thing I need to execute the connections. I go to device, then you can go to, I will just directly enter the IP address of my panel, 62. Okay, and then now my PC is connecting to the panel. Now we need to add a EtherCAT master, so we'll right click, add add device and go to Fieldbus, EtherCAT master, and add it. Great. Now a EtherCAT master is added in your project. So when we close the windows that we don't need, we open EtherCAT master. The first thing, you need to choose which interface that you will use for in your project. So go to this source address/let. Now, as I mentioned before, the panel that I'm using here is 7007M. I have 3 Ethernet port, so you need to choose which port you need to configure as the EtherCAT master. In this case, I will use Ethernet ETH0, so I just choose this one, press OK, done. And then I just right click and then scan for device to scan all the EtherCAT slave in my network. It maybe then spend you, depends on how many nodes that you're connecting, it may spend you half minute something. Great, all the device can be scanned in Codesys. So you just click EK101 and then copy the project, and then great, all the slave is copied from the real hardware, actual hardware configurations to your project. And before I start the other step, I would like to tell you that by default, there's not so many EtherCAT slave from Becchoff is installed inside Codesys. So you need to go to Becchoff's website and then to download their configuration files, XML files, and then go to tubes and device usability, and then press install to install the device that you need to import into your system. Okay, so now I have my EtherCAT master. I have a EL6910. So in this case, I need to configure this one. So the first one, I will click the FSOE inside the logic IOs. So here I have 3 items that, because this slide I tell you before, I installed 3 safety modules in my EtherCAT network, EtherCAT couplers. So you'll see here's 3 FSOE modules in here. The first one is the EL1904. The second one also the same, so it should be this 2 sub. And the last one is the safety output EL2904, so it should be the last one, EL2904. Okay, now I'll show you how to configure the module, this module one by one. You can click the FSOE, the first one. Here is the configuration windows. There's some parameters you need to configure. The first one is the FSOE address. So where can you find the FSOE address? Then when you take out your modules, your safety module, even this EL6910 or EL1904, all this type of safety module, they have a deep switch for you to configure the FSO address. So in here, I configure the address is 10, so I just enter 10 for my first FSOE address. And for the connection ID is same. You need to configure it as a Unicode number. If you configure the same number for couples of FSOE slave, when you try to download the project to the EL6910, then the Codesys will give you an error that you say this connection ID is used more than 1 time. So what can you do? I will just change the ID as same as the FSOE address. Oh, this 10. Great. Oh, I forgot the other things I would like to mention you is for the EL6910, you also need to configure this safety address. Go to EL6910 and then click this safety parameters. Here also have a FSOE address. Now in this case, the config is 1 and this is the default FSOE address. So we also need to take out your EL6910 and then to check actually the deep switch settings. In this case, I just setting is to 1. Okay, so for the FSO address is finished and the connection is finished. Now we can do the IO mapping. So here is the IO mapping. You need here the safety data. You can say the data type is safety boot. So you can map, create a safety variables in here to use in your safety program. So I just give it some easy understand name. For example, as in ID 10 channel 1. Then I just copy it, channel 2, and then channel 3, and then channel 4. Great. It works. Okay, so and then this one's config is okay. The FSO address is okay. Connection address is okay. IO mapping is okay. Then we can close it. Then go to the next module. So in the next module, I will not use any input in this time. So what I need to do is just configure the safety configurations for the FSO address and the connection ID. Great. And then for the last one is the FSOE safety output. The safety output EL6910. So I need to go to safety configurations to configure this exactly correct FSOE address. It's 15 in this case. So I just configure also the connection ID as 15, and then go to IO mapping. IO map is a more beautiful name, so I just copy this one, and then paste in here. This one is not in. Is this OW? So it's O1, O2, and then O3 and O4. Great. Done. Finish. No, not difficult. Very easy. And then now we can create our safety project, a safety program. So how to do this? Let's click the safety logic, right click. Oh, sorry. Safety apps. Sorry, safety apps. Right click, add object, point, and then just enter your point name. So here is the safety editor of Codesys for you to program the TwinSAFE project. But before I show you how to program the TwinSAFE project in Codesys, I need to close it first. I need to show you how to map how to create the normal variables. So why did you do this? So because if you use Siemens safety PLC before, then you will know that actually it's not good, but you can directly use the safety variables in the non-safety program, and also you can directly use the normal variables, non-safety variables in the safety program. But for TwinSAFE, it is impossible. If you see my previous video for the TwinSAFE, then you will know that if you use TwinCat, we need to insert a slot for us to exchange the data between the safety data, safety variables to unsafety variables. So Codesys is also the same. I'll show you how to do this in this very, very important step. So right click, add object, so logical device. So here is so many stuff that you can add here, not just you have field bus, you have local device. So I'll show you how to add the local device. There's two types of add in this case, in this tutorial. The first one is exchange 8 bits from EtherCAT safety module to PLC. It means it's a 8 bits data from your EL6910 to PLC. I'll add this one. Okay, the screen conversion screen is same. I'll just close it first. I'll add other one. So other one is exchange 8 bits from PLC to EtherCAT safety module. What's the mean is the same. You see the meaning here is the data from your Codesys PLC, in this case my extra panel, to the EL6910. Great. You add 2 slot. Now we close it. We can go to point, right click, probabilities. Then is a very important thing you need to configure here is group IOs. If you, as I mentioned before, if you watch my previous video for TwinSAFE, you know that TwinSAFE has a groups of IOs allow you to control your group logic. For example, in here the input is called run stop, is allow you to trigger the execution status of your groups. For example, you need to stop the logic, run the logic, or run the logic. You also have an error acknowledgement to acknowledge any errors that of your function or of your safety group, TwinSAFE groups. And for the output side, you also output some status of your current groups. For example, any function blocks error, or is the communications error, or is it always error. So we need to map all this data. If you don't map this data, and when you try to download your project to TwinSAFE EL6910, then Codesys will give you a error that says, hey, you need to map this stuff. So I'll show you how to map this one. First one, that's why the reason that why I need to add the local, this type of local logical slots for us to exchange data between our safety project to non-safety project. So for example, I will configure the data from my safety terminal. I think from safety terminal, from PLC to safety terminal. So from PLC, so what kind of signal that you need? From PLC, you need a run signal to turn on my to latch my TwinSAFE group to be run status, and I also need a acknowledgement signal for us to acknowledge any errors that inside our TwinSAFE safety group. Then, but don't worry, after we create the safety program, we'll add a little bit more of variables. Then you will, don't worry, just follow me. I will do this all step by step. Okay. And then we need to configure some variable is from EL6910 to PLC to our, it means that our code is normal PLC. So what kind of signal that you need in here? For example, you need the status, right? So you will have FB error, right? Then you will have our error. Then you will have I forgot, you have what? Com error, right? Com error, right? So after you create all this stuff, what you need to do is go back to the point, right click, probabilities, and then group IOs, and then press this button to map all the data. The first one is run, and then ACK, and then FB error, and then com error, and then files our error. Apply. Okay, great, done. Then we can open up points. So here is the safety editors for us to make this TwinSAFE logic. In the right hand side, the toolbox allow you to add the function blocks. So here you have analogs and boot type. In this case, I only use boot types. The first one, I would like to add a timer. So just FP underscore T on directly dropped here, and then the instance will automatically create for you. So it's very great. So in here, the operation is actually the same as the timer that you play if IEC 61113. So in here, I will just call SDI as in ID10 channel 1. Then I'll give this a 3 second of delay. Then I would like to output some signal. So how to edit? You just select here, right click, and insert assessment. Then you can select the variables you want to output in here. So I would like to output this signal back to my normal Codesys PLC. So I need to add one more variables in here. I will go to from EL6910 safety module to PLC, and then here I use my timer on. Okay, so I will just close it, and then here my timer on. Done. Your first logic is finished. Then I add one more program in here. Right click and insert network below. So it's one more line that allow you to add other program. I will add a function block. It's called FB stop. It's the library allow you to control the emergency stop. I will not explain too much in here, so please reference to the online help of Codesys, then you get a very detailed information from them. So the first one, I would like to get a reset signal. So these reset signals allow me to reset my function block in this of this fp_e stop. So I need a signal from my Codesys non-safety runtime, non-safety PLC also. So this time use from PLC to EL6910 safety module. I will add a variables called estop ESTOP_ACK. Great. Then I close it. So here ESTOP_ACK. Okay, then for here I'll just copy this signal. Actually no need all, but because this is tutorial, I would like to show you all the parameters in here. So I just copy to 1 V and then 4. Here's 4. Okay, here's 4, and then I have 5, and I have 6, and then I have 7. I have 8. Great. And then here is the feedback. BEDM is the feedback. So actually I didn't connect the feedback that from the in this tutorial. So I just directly copy my safety output in here. Great. Okay. So actually in here, so some variable, some parameters is have a yellow highlight. It means it's safety variables. You need to pass the safety variables inside. So for this one, it's a normal variables. And then there is some span time. So I will just put 100 milliseconds because this is at least you need 100 milliseconds. So 100 milliseconds, 100 milliseconds, 100 milliseconds. 100 milliseconds. And then for the reset time, so I don't need any delay in here, so I don't use this feedback, so I just put 0 millisecond. And then for the delay output is the setting allow you to turn on this bit, this device, and a specific time. So I put it as a 2 millisecond. Okay. Then here I would put the right click and then is assessment, and then SO channel 1. For I also would like to pass all these 3 signal back to my normal program, right? So I will go to from EL6910 safety module to PLC, and then stop OK, stop OK, stop error, and stop delay OK. Great. And then I'll close it. And then the first one I will it is stop delay OK. So this one is stop error. But I would like to add one more output in here, so I just select here, right click, insert assessment, and then I just say stop OK. Oh, sorry, stop OK. Great. So my safety program is finished. So we need to double check. I set the property in here. Okay. I set each safety address and the connection ID is okay without any error, no bit duplication on the connection ID and the FSO address. So, and then we need to create the variables in our Codesys PLC also. How to do this? You need to go in, can click on the applications, right click, add object. And then here is the options is logical exchange GVL. So add this one, and then here is a drop down list. I will choose ESM from PLC, and then all the data you automatically generate from that you define in here. So do the same stuff again. Add one more logical exchange GVLU. Great. So I create all this data, and then I need to create some program, because if you don't use this data, don't use this variable, it will not update in your Codesys project. So the first one I will use I will create reset, and stop arc is a boot type, and then I have a run, also a boot type, and then I'll have a com error. I will have a com error, FB error, and I'll have a OW error. OW error is also a boot type, and then I have a stop, and I have a stop delay, and I have a stop error, also a boot type, and finally I will have a my timer delay on, also a boot type. Great. Now I can use it in my project, in my program. So for logical GVLU doc arc is equal to reset, and then logical doc stop arc is equal to stop arc, and logical doc run is equal to run, right? Okay, I like to not make you confused. Okay, I have com error. I would like to get the com error, right? Com error is equal to logical tier 1 dot com error, and I have a FB error is equal to logical 01 dot FB error, and I will have a OW error is equal to logical 1 dot OW error. Great. And then I have a stop is equal to logical 1 dot stop. Okay, I have a stop delay is equal to logical GVL1 dot stop. Okay, and finally I have a stop error. Come on, stop error is equal to logical 1 dot what? Stop error. Great. And finally I have my timer delay on is equal to logical 1 dot my timer on. Great. Okay, now we can download our project. I hope I don't have any error. Go to build, generate my code. Great, there's no any error, so we can download our project to our Codesys PLC, and then we can press the pay button. Great, you can see all these stuff is in green, but just EL6910 is orange because I don't have license. And now it says status is unknown. We need to download the safety project separately. I think if you watch my previous video, you see it's the same operations. So go to safety apps. Save EL6910. I close this one, not use, and I save my project. I press download project. Then here you need to log into the EL6910. Then you have the username that direct default is as administrator, so we just keep it. And for this password, it's TwinSAFE, so I just prepare it in here. So it should be TwinSAFE. I put TwinSAFE in here. Then for serious number is you need to take out your EL6910 and then just check the number that is marked on your modules. In my case, it's 119.8.182. Okay, press OK, and then I'll start downloading. Then you need to check, is this project, you need to download this stuff, is that okay? Yes, press close, and then you enter my password again. So I will enter my password again here, press OK. Great, download is successful, and you see the point is changed, stop. It means not unknown anymore. So we finish. Then I open my camera. Then you can see, we can check the hardware to see actually this project is work or not. Okay, now we turn the camera. In the left hand side is our camera, right hand side is our Codesys project. Now, so first of all, I would like to trigger my safety group from stop to run. So how to do this? I can just go to press the run button here, and then right, and see how the status change to run. For about 3 seconds, my timer delay on will always turn on, and then I would like to just a second, just adjust here. I would like to adjust this one. I need to turn on this 2 signal. How to do this? I need to acknowledge my FB_e stop. How to do this? And actually this function block is accept a down signal. So how to do that? You need to turn on the signal on and then off again. So I'll show you how to do this. So here is the e-stop egg, and I turn it to on, then I turn it to off. Great, you see this one turn on, and you see that here the alarm is all turned on, the relay is turned on. So in this case, I will go to press the e-stop, and then you see the output will be turned off. Just wait a second. Okay, and then you see the signal now is turned off, and the safety window also turned off. So you see the safety logic is running properly without any problem. Okay, I think my video in here, my tutorial in here is enough. I hope you, after you watch my video, you know how to use Codesys to configure a EL6910 or 6900, etc. And it was very same. If you like my video, please like it and then share to any people that would like to do some similar stuff, and please give me some comments if you have any problems. I will try my best to help you. So please have a good day. I hope I can see you again. Bye bye.